Hello everyone again. For today's session, I'm going to show you an example here on creating how to create interrupt OBs. Right? I think you heard about interrupt OBs, cyclic interrupt, and time of the interrupt. Right? Different OBs are there. OB numbers have been already predefined. Okay, they are under some OB groups, right? So that I already explained in one of my video. Okay, there is your okay, you can see that in the playlist. Okay, so today we are going to see how to create these OBs, and one example also I will show you how these OBs works. Okay, so first of all, what we do is we create OB number 10. Okay, so OB number 10. What is OB number 10? In which group it is coming? It is coming under time of day interrupt. Okay. So when you double click on the CPU. Okay. CPU means in your software. Okay. Not on hardware. On your software, you can see in hardware configuration window. When you open this hardware configuration window from this PLC1 example, and there you will open this hardware and then double click on this CPU. Here you can see it has opened this CPU properties, right? In this, we are having cycle or clock memory, right? We're having retentive memory. So different tabs are available here. Interrupts. In these interrupts, we are having hardware interrupts like OB number 40, and it is having some priority number. Okay. Number is 16 for this OB number 40. That is under coming under hardware interrupts. So we can see in this interrupt, we are having OB number 42, 47, some group number of OBs are already predefined. But for this CPU 314C, 2PN by DP, it is supporting only one OB number 40 out of all this, or out of all these OBs. Okay. Now, other OBs like time delay interrupts. Okay, for generating some delay time. Okay, so for that we are having OB number 20 and 21. Similarly, we have other OBs like asynchronous error interrupts. That is OB number 82, 83, 85, 86, and 87. So all this already I have explained in my last videos. Okay, one of my last video that you can go through. What are these OB numbers for? Asynchronous errors means anytime. Asynchronous means anytime some errors might occur. Like yesterday we have seen this means in the last video for how to configuring this remote IO modules. Okay, on Profibus. If this is disconnected, okay, for that it shows one error. Okay, CPU goes to stop mode. So your CPU should not go to stop mode. For that, you need to download this particular OB number. Okay, OB number 85 or 86 or 82 like that. So this number you can find in the list. Okay. Now, apart from that, we are having another group of OBs, that is time of the interrupts. So you can see time of the interrupts. Time of day means on some particular date, on some particular time, you want to execute any logic. Okay, or from it should be one time only or continuous. Okay, from what time it should start. Okay, that also you can mention here. Okay, for example, when I select this time of the interrupts, there you can see OB number 10, which is active. Okay, and the priority is 2. So here priority means event. Okay, it's like an event number, means when this event should occur. Say OB number 1, OB1 is having the least priority. Means its event number is 1. Okay, for OB number 10, it is 2. So Suppose if I'm setting some date and time, so when your CPU is equaling with that date and time, okay, means after 1 hour, we should execute some logic, okay, in OB number 10. So that date and time I'm setting, today's date and time. So what happens when this time is matching, whatever the set time is given is matching with our time, okay. So what happens? It compares between OB1 and OB2, sorry, or OB1 and OB number 10. So which is having the higher priority number, OB number 10 is having higher priority number, that is 2. So it will interrupt OB1. Interrupt means it will stop OB1 for a while, execute the logic in OB number 10 only one time, only one scan, okay, then come back to OB1, okay, only for one scan. That is also happening in milliseconds, okay, it is executed in milliseconds. Now, so any OB, whatever the OB you are having, cyclic interrupt or any other OBs we are having here, okay, interrupts, they're all executed only once, only one scan, okay, and they are coming back to OB1. They are interrupting OB1, stopping OB1 for a while, scan one, and then go back to the OB1, okay. So we're having these different interrupts here, okay. So first today we see with this time of the interrupts. So we need to active this OB number 10. So this is disabled right now, empty box. You click on this active, the tick mark is there, that means it is activated. Then execution, you can see here once, means only one time for every minute or every hour or every day, every week, every month, how you want to execute this logic, when you want to execute this logic. So that you can select here. Say, I want to do it every minute. But when it should start on that particular date, okay, I can mention here as the year today is 2023. Today's date is 23, and a month. Okay. Then start date and okay, sorry, I think we need to change here. First is a month, then the date, then the year. Okay, this is actually the format. First, they have to mention the month, then date, then the year. Now it has taken. Now, in time of day, here it is a 24 hours format. So at what time you want to execute this logic? Say I want to execute like 19 hours. So present time is 19 hours, 12 minutes. Okay. I want to execute at 19 hours, uh, say 17 minutes. Okay. After 4 minutes, I want to execute this logic. Okay. Then I say, okay. Now, so I'll compile this. Because you have made changes in offline, okay, in CPU properties. So you need to save and compile, okay, check for the errors, and then download this configuration again to the CPU. Okay. So, okay. Yes. Minimize this. Then go to the schematic manager window, go to the blocks here. Right click on the blocks, or you can right click here in this window also for selecting the blocks. In this also you can see insert new object, select organization block, yeah, and then OB number 10. If any name you want to mention, okay, you can give any name here. Like I'm giving some example here. And then see okay. Now double click open this OB number 10. Now here I will take one logic like move logic here. I want to move some value like 50 into some memory and W56 something. Okay, in some memory, I want to move this 50 into MW56. Okay, let's save this. So I need to download this OB number 10. Okay, so here, as this is also an organization block apart from this OB1, and we are not calling this OB number 10 in OB1, right? So you can directly download only this block. Okay, so as I have not downloaded other blocks here, right? So I download all the three here. Now, number 10. So when I go online, you can see it is showing off. When this will be on here, when the time, okay, reaches 1917. Still 2 minutes are left, okay. So we need to wait for a while. Now take this also. MW6. Right now there is no value here, 0. Okay, so 1 more minute we need to wait. So this is one of the method here. Okay. In logics, okay, you need to scan or execute after some time. Okay. So in OB1, what is happening? Your logics are scanned continuously in milliseconds, like if your CPU is having 0.1 milliseconds for 1000 bits. Okay, scanning 1000 bits in 0.1 millisecond. Okay, that means if your logic is huge, okay, so it takes more time. Okay, now you can see here, it has executed here. The value, it has moved 50 into MW56, right? So only one scan. Okay, now it is one of the example here for creating this OB number 10. So one more example we'll just see here, that is your OB number 35. Okay, so that you can understand the difference here between time of delay and time of the day interrupt and cyclic interrupt. Okay, so I'm going back to hardware configuration. In this, we have interrupt. You can see time of the interrupt. Okay, so every minute, okay, every 1 minute, it will be transferring this value. Okay, now, so what I do, I go to the cyclic interrupt. I create one cyclic interrupt. Okay, in this, you can see OB number 32, 33, 34, and 35 are enabled. So any one of these 4 blocks we can use. We are having how many? There are 9 blocks available in cyclic interrupt, but any 4 can be used here. Only 4 are enabled, so these 4 you can use. Okay. So I will say mostly use are say OB number 35, which is executed for every 100 milliseconds. Which is executed for every 100 milliseconds. Okay. Now you can increase the time, like for every 5 seconds if you want to execute. So I will set the time as 5000. Means every 5000 milliseconds means 5 seconds. 1 second means 1000 milliseconds. So 5000 milliseconds means 5 seconds. So I'm setting the time as 5000 milliseconds for OB number 35 in cyclic interrupt. Then say okay. Cyclic interrupt means from beginning, every, say I have set the 5 seconds, right? So every 5 seconds, that block is scanned only one time. It interrupts your OB1, scan once, and come back to OB1. Means some logic we have to scan after some delay. Okay, not continuously in milliseconds. Okay, milliseconds means your scanning will be very fast. Okay, so some data is changing after few seconds, like 2 seconds or 3 seconds. Okay, so when the data is changing after 3 or 4 seconds or after some more time, so why should I scan that in less time, right? So just like in PID calculation or PID application, in that your data is changing slowly, right? So you have to update that data with some time, with some delay, which is not possible with OB1. So generally, most of the engineers, okay, uh, means experts, they are using OB35 for making for PID calculations. Okay, in this OB35, they are writing the logics. They're calling this OB block or PID blocks and executing the logics. Here, after creating this OB35, okay, selecting the OB35, sorry, then you can download this hardware configuration here. Because we have made the change in offline, we need to download this. We download, okay, okay, okay. Yes. Now, similarly, just like OB10, I create OB number 35 here. Version block, OB number 35. Double click open this block. Now, here what I do, I write a small logic using integer function add instruction. Okay, in this add, say I take some memory MW20, MW20, then add by some value like 5 and MW20 again. Means whatever values there in MW20 will be added by 5 and it is stored in MW20 again, just like incrementing A is equal to A plus 1 order. Okay, so I just save this and you need to download this one. And one more thing you need to change here. For this example, logo number 10, what are the values coming in MW20, right? MW20 after 1 minute, okay? So this OB10 is executing. So whatever value comes here will move to MW56 for every 1 minute, okay? So I just save this one. Now download this both the blocks here. OB1, OB10 and 35. Download. Yes, yes. On now. So you can see every 5 seconds this will be incremented. MW20 I'll take it here. So here timing is 1923. So it becomes 1924. Whatever value is here in MW20 will move to MW56. So here it is MW20 address I have given in OB number 10. Right? So both I am linking here. You can see that. So OB number 1 is executed very fast. Okay. But some logic you have to execute after some delay, after some time. Okay, so such logic you can write in OB number 35 or OB number 10. Okay, by generating some delay when it should be executed. So there's a purpose of using this interrupts. So you can see right now what's the value here? 70. Okay, the time is 1924. Now then after 1 minute you can see the next value, whatever the value will be there after 1 minute. So OB35, what is happening? Every 5 seconds, this is executing only once. It's not continuously executed. If you do this add instruction in OB number 1, okay, you can see the difference. I will show you that. If I do this add section will be number 1, it's very fast. And W30 something, and 5 and W30. See here how fast it is adding. Okay, it's very fast. But if you see here in OB number 35, every 5 seconds, only one time it is running, right? So if you see here in OB number 10, okay, it's right now, it's not executing this right now, so we consider value here. Okay, so this is a difference between OB number 1, OB number 10, and 35. Okay, time of delay interrupt, cyclic interrupt. Okay, there's one more interrupt that is hardware interrupt, that is for your analog signals. Okay, if your analog value means you are having some range 0 to 10 volts only, or 4 to 20 milliamps only if you are setting the low limit and the high limit, and your signals are crossing these limits. If it is going beyond 10 volts or if it is going beyond 20 milliamps, that hardware interrupt will be executed, but only once. Okay. So what this OB is doing, hardware interrupt, if your CPU is going to stop mode due to that error, if it is crossing the limit and your CPU is going to error, okay, your CPU is stopping, right? Your CPU should not stop. It should remain in run mode. For that, we need to download that hardware interrupt block, that is OB number 40. Okay. So likewise, we are having different OBs for different errors. For that also, I will make one small video. Okay. How to generate, how to check the errors, where we can see the errors in schematic manager, how to find out the errors. Okay, a small video I'll make it and upload. Okay, so this is one example for your interrupt OBs. Thank you.